Ever wondered how computer programs come to life? Today, we dive into the world of C++ programming to unravel this mystery. C++ is a powerhouse in the realm of coding, a high-level language that's integral to software development. It's the cornerstone of programming, enabling us to create applications, design games, and even program hardware. Imagine C++ as a digital construction kit, providing the building blocks to create intricate, efficient, and versatile programs. It's a language that communicates with the computer, instructing it to perform specific tasks. From operating systems to web browsers, C++ plays a crucial role in powering the software we use daily. It's the unsung hero behind many popular software applications and games. It provides the infrastructure, the framework, the very foundation upon which these programs are built. C++ is the backbone of many popular software and games. But how does it work? Let's dive deeper. To understand C++, we first need to grasp the basic components that make up its structure. Let's dive right in. C++ is a language of syntax, much like English or Spanish, and its grammar rules are central to creating a functioning program. The first thing to understand is the concept of variables. Variables are essentially named containers that store information. They're like labeled boxes in a warehouse, each holding a specific type of data. Next, let's talk about data types. In C++, we have a variety of data types, each with its own distinct characteristics. Some of the most common ones include integers, which are whole numbers, floating point numbers, which are decimal numbers, and characters, which are individual letters or symbols. You can think of these data types as different sized boxes. An integer might be a small box, a floating point number a medium box, and a character a large box. Each one is designed to hold a specific kind of data. Now, to manipulate these variables, we use operators. Operators are the actions we perform on our variables. They include arithmetic operators like addition and subtraction, comparison operators like greater than and less than, and logical operators like and or. Imagine our boxes in the warehouse again. The operators are the warehouse workers who move, stack, and organize the boxes according to specific rules. They ensure that the boxes or variables are manipulated correctly. Together, variables, data types, and operators are the building blocks of any C++ program. They allow us to store, manipulate, and evaluate data, forming the groundwork for more complex structures and functions. Remember, understanding these basics is like learning the alphabet before writing a novel. They might seem simple, but they're fundamental to everything that follows in C++ programming. Now that we have a grasp of the basics, it's time to learn about how these components interact to create a program. In C++, the flow of the program is just as important as the components that make it up. Control flow, as the name suggests, is all about controlling the path or flow that your program takes. It's like the traffic signals for your code, dictating when and where to go based on certain conditions. Let's talk about the most basic control flow statement, the if-else. It's like a fork in the road. If a particular condition is true, the program takes one path, executing a specific block of code. If it's false, it takes a different path, executing a separate block. Then there's the switch case statement, a more efficient alternative to a series of if-else statements. It's like a multi-exit roundabout where the program chooses the exit based on the value of a certain expression. Each exit corresponds to a case, and the program jumps to the corresponding block of code. Now, imagine you want your program to do something repeatedly, like a car going around a roundabout multiple times. That's where loops come in. A while loop keeps going as long as a condition remains true. A for loop, on the other hand, repeats a block of code for a specific number of times. And the do while loop? It's a special one. It guarantees at least one round, regardless of the condition. It checks the condition only after the first execution. But what if you want to break out of a loop prematurely, like taking an unexpected exit off a roundabout? That's where break and continue statements come into play. The break statement acts like an emergency exit, terminating the loop immediately, while the continue statement skips the rest of the current iteration and jumps to the next one. Control flow gives a C++ program its logical structure. It's the roadmap that guides your code, taking it from one statement to another, from one block of code to another, based on specific conditions. But to make a program truly functional, we need to understand functions. Functions are the heart of a C++ program. They contain the instructions that tell the program what to do. As we delve deeper into the realm of C++, we come across functions, these indispensable tools that help us organize our code better and make it more readable and maintainable. A function in C++ is essentially a block of code that performs a specific task. It's like a mini program within your program. You give it a job, it does the work, and returns a result. This is the basic principle of a function. They come in two flavors: built-in functions already provided by C++ and user-defined functions crafted by the programmer themselves. Built-in functions include the likes of cout for outputting to the console or sciot for calculating square roots. User-defined functions, on the other hand, are custom-made to suit the specific needs of your program. But what if we need a function that's not built in, and crafting one ourselves is too complex or time-consuming? That's where libraries come in. Libraries in C++ are like ready-made toolkits, filled with pre-written code that you can use to perform complex tasks without having to reinvent the wheel. You've probably used a library already without realizing it. Remember useTash include? That's a directive to include the IOStream library, which provides functions for input and output. There are libraries for almost everything in C++, from handling strings and mathematical computations to graphics and game programming. They are a testament to the collaborative spirit of programming, where coders share their work to help others create more efficiently. This combination of functions and libraries empowers you to build complex programs with relative ease. It's like having a team of expert coders at your disposal, ready to lend a hand whenever you need it. Functions and libraries make C++ a powerful and efficient language. But there's one more topic we need to cover: object-oriented programming. Object-oriented programming, or OOP, is what sets C++ apart from other languages. At its core, OOP is a design philosophy that structures a program around objects rather than procedures. This shift in perspective allows us to create more flexible and reusable code, which is a major advantage in complex programming projects. So, what exactly are these objects? An object is an instance of a class, which is essentially a blueprint for creating objects. Classes define the properties, also known as attributes, and behaviors, also known as methods, of the objects created from them. Let's imagine we're creating a video game. We could have a player class with attributes like name, health, and score, and methods like jump, run, or shoot. Each individual player in the game would then be an object of the player class, with their own specific name, health, and score values. But OOP doesn't stop there. A powerful feature of OOP is inheritance. This lets us create new classes based on existing ones, inheriting their attributes and methods. For instance, in our game, we might have a super player class that inherits from the player class, but with additional attributes or enhanced methods. Then there's polymorphism, which allows us to use a single interface to represent different types of entities. In simpler terms, it means one function or an operator functioning in many ways depending on the context. Lastly, we have encapsulation, which is the practice of hiding the details of how objects work. This makes our code safer and easier to use by preventing outside code from accidentally changing an object's state. With a grasp of OOP, we now have a solid understanding of C++. But remember, practice is key to mastering any programming language. So, what have we learned about C++? We've peeled back the layers of this powerful programming language, starting with the basics. We've learned that C++ is a high-level language that gives us the ability to create complex software applications, all while keeping us close to the machine code for efficiency. We've delved into control flow, understanding how to use loops and conditional statements to dictate the path our program takes. Next, we've explored functions and libraries, the building blocks that allow us to write reusable, modular code. We've seen how libraries in particular can save us time by providing pre-existing solutions to common problems. Finally, we've touched on the concept of object-oriented programming, or OOP. This paradigm allows us to structure our code in a way that's both intuitive and scalable, making it easier to manage as it grows in complexity. So keep practicing, keep exploring. Remember, every great programmer started somewhere. Your journey into C++ is just beginning. Happy coding!